Today we're looking at using the properties of logarithms to expand and condense logarithmic expressions. There are three properties we want to look at today. So what do I mean by expand?
Make big.
Make bigger, and condense means we want to make it smaller. So that's what we're looking at doing today. Like I said, there are three different properties we want to look at. Pretty basic, and you should have seen them before because this should have been touched on in Algebra 2. So the first property is, if I have two things being multiplied inside of a log, such as A and C right here, they can be separated into two different logs by addition. So this can be separated into log base B of A plus log base B of C. So if you have a log with stuff being multiplied inside of it, you can separate it into two different logs by adding the logs together. That's the first property. It doesn't just go from the left to the right, it can also go from the right to the left. So I can take multiple logs and turn them into one log. So we'll do both today. So there's the first property. The second property is related. So this time I have two things being divided inside of a log. What do you think happens here? Separate by subtraction. Good. So this will be log base B of A minus log base B of C. So that's the second property.
Where do you get C?
I don't know. This should have been C.
Oh, okay. Okay.
So that's the second property. The third property, if I have log base B of A to a C power, that can be rewritten as C log base B of A. So that means if I have something with a power inside of a log, I can take that power and move it to the front of the log. And I can also go the reverse. If I've got a number in front of the log, I can move that number to the exponent inside of the log. Again, both of these work both ways. I can go from the left to the right and from the right to the left. So if I got multiplication inside a log, I can separate into two different logs with addition. If I've got division, I can separate with subtraction. And if I have an exponent, I can move the exponent to the front. Those are your three properties we're going to use today. So if we go back to that problem we were doing earlier today, which was log base 4 of the fifth root of 64, let's see how we can use the properties, one of those properties we just learned, to make this problem a little bit simpler. You tell me, which one is it?
Well, when you change it to 4, 3.
All right, you're getting ahead of me though.
Well, it's a power.
It's
So
a
you're
power.
gonna do
What
the
power
last
do I have?
To the negative fifth.
I have 1/5. My power is the 1/5. This radical here, we need to realize anytime I see a radical, that's the same thing as having a power there. And what did we just learn we can do with the powers? We can move it to the front of the log. Okay? Then we should be good enough to where we can evaluate that log in our head. What is that log asking me to find?
What makes 6 to the x?
What exponent of 4 will turn it into 64? So what exponent turns 4 into 64? 3. So that means this is 3, so that means we end up with 3/5 as our solution, which is the same answer we got earlier today. But I think you'll agree that once you get used to this, this is much quicker than what we're doing earlier. All right. Let's do another one similar to this. So I have 3 times log base 5 of the 4th root of 25. 3 times log base 5 of the 4th root of 25. So what do I want to do?
Can you move 1/4 to the front?
I move 1/4 to the front, so what does it turn into? 3 over 4. So I have 3/4 log base 5 of 25. So I move the exponent. Once I move the exponent, we should be able to evaluate that. So that turns into 2. And then we reduce and we get 3/2 is my solution. Okay? Matthew?
So with moving that exponent over to the front, if there's already a number there, it's just multiplying it.
Correct.
Hold on now. I didn't even print it up.
Really, really
Alright, so I have log base 9 of 6x squared y to the 5th z. And the directions when you see this problem are going to say we want to expand this logarithm. We want to use the properties to expand a logarithm. When you expand a logarithm, you do it in 2 steps. The first step is to write out your multiple logarithms. So how many logs am I going to end up with on this problem? 4. Because I have 4 things being multiplied. I've got a 6, I've got a 6, I've got an x squared, I've got a y, and I've got a z. So however many things are being multiplied or divided, that's how many logs you're going to end up with. So the first thing you do is get all your logs. So log base 9 of 6 plus log base 9 of x squared plus log base 9 of y to the 5th and plus log base 9 of z. So the first thing you do is get all your logs. Then what do you think the second thing is? Move your exponents. Very good. So the only one that has exponents are the 2 in the middle. So I have log base 9 of 6 plus 2, log base 9 of x plus 5, log base 9 of y plus log base 9 of z. And that is what it's looking for.
Oh, okay.
So figure out how many logs you have and write those down. And then the second step is to move the exponents to the front. That's the process whenever you're expanding a logarithm.
Okay.
Okay? Let's look at the next one.
No.
That's it on that problem, yes.
Oh.
What's your question?
Is there a third property?
Say it again.
Is there a third property still? Did we only have 2?
We've done 3 properties, yeah.
Have we done examples, bro? I thought plus and minus are the same property.
Next one.
I'm so sorry.
I have log base 3 of p squared times q over the 5th root of 3q minus 1.
What?
That's a key.
Wow.
That's a q.
Q.
Log base 3 of p squared times q over the 5th root of 3q minus 1.
It's scary. Q.
Holy smoke, people.
It looks like
It does look like it.
Thank you.
Oh,
Congratulations.
that looks like a little snake now.
So, I want to expand, so what's the first thing we want to do if we want to expand?
Cry.
Find out how many
Find out how many logs I'm going to need. So how many logs will I need?
3.
I will need 3 logs.
Oh,
Yeah. Just forget I said that.
Alright, so what's inside the first log? P squared. The second log? Q. And the third one?
That big thing.
Alright. Then I need to decide whether or not I have positives or negatives in front of them.
Oh, positive.
And what's an easy way to determine whether or not it needs a positive or negative in front of it?
If it's multiplying, that's what it was.
If it is in the numerator, it needs a positive. If it's in the denominator, it needs a negative. So this one's in the denominator, which means a negative. So that means this one has to be a positive. That's the easy way to figure it out.
Where did they get long?
Oh, okay.
That's
Don't judge me.
Alright, so there's step 1. Step 2 is move my exponents. So I've got 2 log base 3 of p plus log base 3 of q minus 1/5 log base 3 of 3q minus 1. Now, I like to put that 3q minus 1 in parentheses over there. So make sure you know that 3q minus 1 is inside of the log. So 2 steps on expansion. What are the 2 steps?
Find out how many
Find out how many logs there are, figure out whether or not they need to be positive or negative. It's the second step. Move the exponents. Matthew.
So when you have numbers that you're dealing with, along with all the exponent or with all the letters and stuff, do you fully work out what you can, or do you leave those?
If you can work them out, work them out.
Okay.
Alright, next one. Now we're going to go the opposite direction. We're going to condense.
Yeah.
So I have 7 log base 3 of A minus 2 log base 3 of 8C plus log base 3 of B. And I want to condense.
Pardon the interruption. At this time, we need seniors, last names E through S. We need their senior stated in the library at this time.
This together?
Yeah,
we're
Is that
condensing
A
it.
minus 2 or
Okay.
I used to so if it's in A and it's
So,
backwards to minus.
Natasha makes a good observation. We should be doing what in comparison to what we just did?
The
The reverse. So what were our 2 steps when we were expanding?
How many
Logs I needed, and then what? Moving the exponents. So if I'm doing the reverse, what do I need to do first? Move the exponents. So I need,
Is the goal to get 1 log?
that is correct.
Okay.
So move the exponents, and then as Matthew said, they should, all my logs should turn into what? I should turn into 1 log, and that's where a lot of people mess up. A lot of people won't turn it into 1 log. They'll turn something like this into 2 logs, and I'll show you what a lot of people tend to do. Okay, but I know I'm dealing with 1 log. Now it's just a matter of where does everything go, and how do I figure out where everything goes?
Would you do it like in order, so like A and B, then well, okay, the second one, log base 3 AC2, since it's negative, does that mean there's gonna be a denominator?
That is correct.
Okay, so you're gonna do log base 3 A7, then B would be plus B,
No, not
or
plus
just
B.
B
Times B.
times B, and then over AC squared.
That is correct. So A to the 7th, B over 8C squared. So what are we really looking for, Kurt?
I'll put the positives at the top and the negatives in the
If
bottom.
it's a positive log, it's what's inside has to go on the top. If it's a negative log, what's inside has to go on the bottom. That's the easy way to remember. Yes.
So if we wanted B on the bottom, would it have to be a negative log base 3B?
Yes. If B needs to be on the bottom, that would be a negative.
Okay.
Or this whole thing would be in parentheses.
Okay.
Because if it's all in parentheses, then that means the negative goes to both. Alright, so if I am condensing, first step is
Move
move the exponents, and then I need to realize that I'm ending up with 1 log, and then I just got to figure out if it's going in what's numerator and the denominator. Now, here's what a lot of people do to me on this type of problem. That is a common answer I get on this type of problem. is that they'll do log of what goes in the top divided by log of what goes in the bottom. Please do not do that.
Do you come out with a different number?
And yes, that is incorrect. That is incorrect. I need to remember that when I am condensing, how many logs should I end up with?
One.
You should end up with one log.
No matter what.
So that is using properties of logarithms to expand and condense logarithms. Yes.
Like that?
Huge. For instance, let's say log base 3 of, let's say I've got 27 over 3. Is that what I want to use?
Yes.
No, that's not what I want to use. Let's say I want log base 3 of 27 minus log base 3 of 3. Okay, what people tend to do is log base 3 of 27 over log base 3 of 3. That's what people like to do too. Okay, where it should be log base 3 of 27 over 3. Okay, this turns into 9, and log base 3 of 9 is no 2. That should give me 2. But if I evaluate it down here, what's log base 3 of 27? 3. And what's log base 3 of 3? 1. So as you see, it does not produce the same answer. So do not do that. If I am condensing, you've got to understand that you should end up with only one log. Okay, how many properties are there? 3. We separate with addition when we have multiplication. We separate with subtraction when we have division. And we can move the exponents to the front.
Yes.
Okay? So, on page, what did I say, 185. Does that match up?
Yes.
Does that look like what it should be?
And evaluate, and expand, and.
Alright, we're doing 20 to 48 even. And then 70 and 78.